Hey everyone, welcome back to Chem Talks.
Your go-to-go place for all things chemistry. I'm Irish Padilla.
And I'm Jerlene Agsino. And today, we're diving into an important concept that's essential for understanding how substances interact in solutions, which is concentration of solutions.
So, let's break it down. First things first, what exactly is a solution? A solution is simply a homogeneous mixture made up of two main components, the solute and the solvent. The solute is the substance being dissolved, while the solvent is the substance doing the dissolving. For example, is a salt water solution. The salt is the solute and the water is the solvent.
And concentration refers to the amount of solute in a given amount of solvent. A solution is concentrated when it has a higher ratio of solute to solvent, and it's dilute when it has more solvent than solute. In other words, it tells you how strong or weak a solution is. Now let's talk about one of the most common ways to express concentration, percent by mass. This tells us how much solute is in a solution, expressed as the mass of solute per 100 grams of solution. The formula is percent by mass solute is equals to mass of solute over mass of solution multiplied by 100, where mass of solution is equals to mass solute added by mass of solvent.
Let's walk through an example together. A solution is made by dissolving 15 grams of sodium chloride in 85 grams of water. What is the percent by mass of sodium chloride in the solution? In the given problem, we have 15 grams of sodium chloride and 85 grams of water. If we sum it up, we will get 100 grams of mass of solution. Following the equation of percent by mass of sodium chloride, which is mass of sodium chloride over mass of solution multiplied by 100. Now, we just need to substitute the values. Percent by mass of sodium chloride is equal to 15 grams over 100 grams times 100. Therefore, the percent by mass of sodium chloride in the solution is 15%. So, for every 100 grams of solution, 15% is sodium chloride.
Here's another example. A solution contains 50 grams of sugar and 250 grams of water. What is the percent by mass of sugar in the solution? Same process, we need to calculate the mass of solution first. 50 grams of sugar plus 250 grams of water is equals to 300 grams. Now that we have a mass of solution, all we need to do is to get the percent by mass of sugar. Let's state the formula first. Percent by mass of sugar is equals to mass of sugar over mass of solution multiplied by 100. Then, substitute the values. Percent by mass of sugar is equals to 50 grams over 300 grams multiplied by 100 is equals to 16.67%. So, the percent by mass of sugar in this solution is 16.67%. This means that in every 100 grams of this solution, 16.67 grams are sugar.
Let's do one more. A solution is made by dissolving 8 grams of potassium chloride in 92 grams of water. What is the percent by mass of potassium chloride in the solution? With the same process, we need to calculate the mass of solution first. 8 grams of potassium chloride plus 92 grams of water is equal to 100 grams. Now that we have the mass of solution, all we need to do is get the percent by mass of potassium chloride. Let's state the formula first. Percent by mass of potassium chloride is equal to mass of potassium chloride over mass of solution multiplied by 100. Then, substitute the values. Percent by mass of potassium chloride is equal to 8 grams over 100 grams times 100 is equal to 8%. So, the percent by mass of potassium chloride in the solution is 8%. This tells us that 8 grams out of every 100 grams of the solution is potassium chloride.
Next up is mole fraction, another way to express concentration. Instead of mass, mole fraction compares the number of moles of solute and solvent. It is represented by the letter X. The mole fraction of solute is calculated as X sub A equals mole of solute over total moles in solution. And for solvent, X sub B is equal to moles of solvent over total moles in solution.
Let's walk through an example. We have 1.25 grams of sodium sulfate dissolved in 65 grams of water. First, we need to find the number of moles of each substance. 1.25 grams of sodium sulfate divided by its molar mass, 142 grams per mole, gives us 0.0088 moles of sodium sulfate. For the water, we divide 65 grams by 18 grams per mole, which gives us 3.61 moles of water. Now, the total moles in the solution are the sum of the moles of solute and solvent. 0.0088 and 3.61 is equals to 3.62 moles total. So, the mole fraction of the solute is X sub A is equals to 0.0088 divided by 3.62 is equals to 0.0024. And the mole fraction of the solvent is X sub B is equals to 3.61 divided by 3.62 is equals to 0.997. Notice something interesting here? The sum of the mole fractions equals 1. This is always true for any solution. So, X sub A plus X sub B is equals to 1. And that's a wrap on our deep dive into concentration of solutions, from percent by mass to mole fraction. These methods are crucial for understanding how substances mix and interact in chemistry.
Whether you're in the lab or just curious about how things dissolve, these concepts are super helpful.
If you enjoyed this episode, don't forget to like, subscribe, and hit that bell so you never miss a Chem Talks vlog.
Got questions or topics you want us to cover? Drop them in the comments below.
Thanks for watching, and remember, stay curious, keep learning, and keep experimenting.